Let's see a more advanced example, translating to multiple languages with MarianMT. I've created a helper function called translate that takes text and a target language code. Inside the function, we dynamically construct the model name using an F string. For example, if the target language is FR for French, the model name becomes Helsinki NLP/Opus MTENFR. We load the appropriate model, tokenize the input, generate the translation, and return the decoded result. Now here's the cool part. We have one source text. Hello, how are you today? We define a dictionary with language names and their codes. French is FR, German is DE, Spanish is ES, and Italian is IT. We loop through each language, call our translate function, and print the results. The output shows our greeting in 4 different languages. In French, bonjour, comment allez-vous aujourd'hui? In German, hallo, wie geht es dir heute? In Spanish, hola, ¿cómo estás hoy? And in Italian, ciao, come stai oggi? This demonstrates how easy it is to build multilingual applications with these pre-trained models. Imagine implementing the same functionality from scratch. It would take months or years of work, but with MarianMT, it's just a few lines of code. Before we wrap up, let me share some best practices and tips for working with machine translation models. First, use pre-trained models whenever possible. Training a translation model from scratch requires massive amounts of data and computational resources. Pre-trained models save you time and money. Second, fine-tune on domain-specific bilingual pairs to improve accuracy. If you're translating medical documents, fine-tune on medical texts. If you're translating legal documents, use legal texts. Domain-specific fine-tuning can dramatically improve quality. Third, pre-processing matters. Proper tokenization and sentence segmentation significantly impact translation quality. Clean your data, handle punctuation correctly, and split sentences appropriately. Fourth, evaluate your translations properly. Use metrics like BLE and Meteor for automatic evaluation, but also conduct human reviews. Automatic metrics don't always capture translation quality perfectly. Fifth, consider your hardware requirements. CPUs are cheaper, but slower. GPUs are faster, but more expensive. Think about your latency requirements and cost constraints when deploying to production. Sixth, use batch processing whenever possible. Processing multiple sentences at once is much more efficient than translating one sentence at a time. This improves throughput significantly. Let's talk about how we evaluate machine translation quality. The most common metric is the BLE score, which stands for Bilingual Evaluation Understudy. BLE measures n-gram overlap between the machine translation and human reference translations. It compares sequences of 1, 2, 3, and 4 words. The score ranges from 0 to 100, where higher is better. A BLE score of 40 or above is generally considered very good. The advantages are that it's fast and automatic. You don't need humans to evaluate. But the downside is that it may not perfectly capture fluency and naturalness. Meteor is another metric that stands for Metric for Evaluation of Translation with Explicit Ordering. Meteor is more sophisticated than BLE. It considers synonyms, stemming, and word order. It has better correlation with human judgment. However, it's computationally heavier than BLE. Finally, we have human evaluation, which is the most reliable but also the most expensive. Human evaluators assess fluency, adequacy, and whether the meaning is preserved. This is considered the gold standard. The code example shows how to calculate a BLE score using Python's NLTK library. You provide a reference translation and your candidate translation, and it returns a score. In practice, you'll want to use a combination of automatic metrics for quick feedback during development and human evaluation for final quality assessment. Machine translation isn't just a research topic. It has countless real-world applications. Google Translate is probably the most famous example. It supports over 100 languages and handles billions of translations every single day. People around the world depend on it for communication. In business communication, MT enables international emails, documents, and customer support in multiple languages. Companies can serve global customers without hiring translators for every language. Social media platforms like Facebook and Twitter use automatic translation, so users can read content in their preferred language. This makes social media truly global. In gaming, localization is huge. Video games need to translate not just dialogue, but also user interfaces, subtitles, and in-game text. MT speeds up this process dramatically. In healthcare, MT helps translate medical records and enables communication between patients and doctors who don't speak the same language. This can literally save lives. And in e-learning, MT makes educational content accessible across languages. Students anywhere in the world can access courses, tutorials, and learning materials. These are just a few examples. MT is becoming essential infrastructure for our increasingly connected world. Despite all this progress, machine translation still faces significant challenges. Idioms and expressions are particularly difficult. Try translating "it's raining cats and dogs" literally into another language. It makes no sense. The model needs to understand these are figurative expressions. Context ambiguity is another issue. The word bank can mean a financial institution or the side of a river. Without context, the model might choose the wrong meaning. Cultural nuances vary by language. Many languages have different levels of formality, honorifics, and politeness markers. Getting these right requires deep cultural understanding. Low resource languages suffer from limited training data. While English, Chinese, and Spanish have millions of translated sentences available, many languages have very little parallel text. Domain-specific terms in fields like medicine, law, and engineering require specialized knowledge. General-purpose models often struggle with technical jargon. But researchers are working on solutions. Multilingual models like MT5 and MT-BART use cross-lingual transfer learning, where knowledge from high-resource languages helps low-resource languages. Zero-shot translation allows models to translate between language pairs they've never seen during training. Context-aware models can handle document-level translation, not just isolated sentences. And active learning with human-in-the-loop feedback continuously improves quality. The future of machine translation is exciting. Let me show you a production-ready example with batch translation and error handling. I've created a translation pipeline class that encapsulates with translation functionality. In the initialization, we load the model for a specific language pair and detect whether a GPU is available. If yes, we move the model to the GPU for faster inference. The translate batch method accepts a list of texts and translates them all at once. We wrap everything in a try except block for error handling. If something goes wrong, we log the error and return empty strings rather than crashing. Inside the method, we tokenize the batch with padding and truncation. The max length parameter prevents issues with extremely long sentences. We generate translations for the entire batch at once. This is much more efficient than translating one sentence at a time. Then, we decode all the results and return them. The usage example shows how to create the translator for English to French, prepare a list of texts, and translate them all in one call. We then print each source sentence with its translation. This pattern is what you'd use in a real production system. It's efficient, handles errors gracefully, and can easily scale to process thousands of sentences. Let's look at what's coming next in machine translation. Large language models like GPT-4 and Palm are showing impressive multilingual capabilities. These models understand language more deeply and can produce higher quality translations. Zero-shot translation is becoming more practical. models can translate between language pairs they've never been explicitly trained on by leveraging their understanding of language structure. Personalization is an exciting frontier. Imagine a translation system that adapts to your writing style, vocabulary preferences, and even learns industry-specific terminology you use. Multimodal MT uses images and visual context alongside text. If you're translating a menu, seeing pictures of the dishes helps the model make better translation choices. Real-time translation for live conversations and meetings is improving rapidly. Simultaneous interpretation that was once only possible with highly trained human interpreters is becoming automated. And finally, better support for low-resource languages through transfer learning means that languages with limited training data can benefit from knowledge learned from high-resource languages. The gap between human and machine translation is narrowing every year. If you want to learn more and start building your own translation systems, here are some essential resources. For libraries and frameworks, Hugging Face Transformers is absolutely essential. It provides easy access to pre-trained models like MarianMT, T5, MBART, and hundreds more. OpenNMT is an excellent open-source neural MT toolkit if you want to train your own models from scratch. FairSeq is Facebook's sequence modeling toolkit with state-of-the-art implementations. And SentencePiece is an unsupervised text tokenizer that's crucial for pre-processing. For useful links, check out the Hugging Face Model Hub at huggingface.co/models. You can browse thousands of pre-trained models. The Opus corpus provides massive parallel text corpora for training translation models. Papers with Code tracks the latest research in machine translation with code implementations. And the WMT Conference, or Workshop on Machine Translation, is the premier academic conference for MT research. Let's recap what we've learned today. We trace the evolution of machine translation from role-based systems through statistical methods to modern neural approaches. We saw how neural MT offers major advantages: better context understanding, improved fluency, and more human-like translations. We learned about MarianMT, an efficient and multilingual model that's perfect for production translation systems. We explored T5 and its flexible text-to-text framework that can handle translation alongside many other NLP tasks. We covered best practices, using pre-trained models, fine-tuning for specific domains, and proper evaluation. And we looked at the future: zero-shot translation, multimodal approaches, and personalized systems. The journey in machine translation goes like this: learn the basics, experiment with models, build applications, and then deploy to production. With the tools and knowledge from this video, you're ready to start that journey. Thanks for watching this deep dive into machine translation, from classic statistical models to powerful neural systems like MarianMT and T5. If you found this video helpful, please hit that like button and subscribe to the channel. Your support helps me create more content like this. Drop any questions or requests for future NLP and AI topics in the comments below. I read every single comment, and your feedback shapes what I create next. Hit the bell icon so you don't miss future videos on machine learning, deep learning, and artificial intelligence. See you in the next video with more AI and machine learning insights. Until then, keep learning and keep building. Goodbye.